So, welcome back. I've seen some of you have found out that there is already cake outside, and I didn't know that, so I hope you already enjoyed it. And I make this short, if you like, or not. Okay, next up is Anne, and I quite like that we have this talk after the last one, because we heard about distributed systems, and now we will hear about distribution and how we will do that essentially. So please grab a seat if you're all. No, nobody's standing, right? Give it up for Anne.
Hi. Yeah, so I'm talking today about running PHP applications in multiprocess containers. And first, let me introduce myself. I'm a software developer. I do PHP for roughly 16 years now. I love Symfony since version 1.2. And I'm in Berlin. I'm the organizer of the Symfony user group. I work with Cosmic since 2021, and at Cosmic we do workshops, trainings for Symfony and React, and we organize user groups and community events, and we love to support teams with their Symfony projects. Oops. Sorry. So, I have brought, let's check one thing, sorry. Not giving me my slides. So, this will now do one thing I don't like to do. Sorry. Right. Right. Okay. So I'll introduce you to the challenge we were facing, and then I'll show you some possible solutions that I was researching, and I'll show you ASICS overlay how it works, and I'll conclude with some recipes that you can use to make using ASICS overlay even easier. So to give you some preface of like why we came to this challenge, and I will tell you the challenge in a minute, just give me a few seconds. We are Dockerizing our applications for a while now, and we do that to put everything in a system that we can actually, that is the same setup as we do have in production. So, and to be as close to production as possible. So when we Dockerize our PHP applications for our dev setups, it's probably looking like this. We have one container running PHP-FPM and one container running a web server, in this case NGINX. And yes, we always have two containers. But why do we have two containers? There are two reasons that I found. Maybe you find more, but two reasons why we are running the setup. And the first one is PHP has no built-in web server. Other languages do have web servers included, like Golang has the net HTTP package, and Ruby has Unicorn, and Python has the web server gateway interface, and they all can like only use one container. But PHP cannot handle HTTP requests by itself. It requires a web server. And so, like, briefly look into it. The client sends an HTTP request to NGINX, and it handles the request to the fast CGI process. It works all through our PHP scripts and then handles, then sends back the output and sends it back, and NGINX then sends it back to the client. So that's the first reason. The second one is there's a mantra of Docker that's always saying one process per container. And here the same question, why should there only be one process? So I never asked myself this before, but for everyone who's always also never asked themselves, I looked into this now. So Docker runs processes in isolation, and this is what we call a container. So you can see it here. There's the Docker daemon, and then it starts a service, which then runs NGINX or PHP-FPM or whichever service that you started. So with isolation, it's meant that it's running its own file system and its own networking, and also this its isolated process tree. And if we take a look into how this container lifecycle management works, it's if you say Docker create, then a container gets created. If you say Docker start, then it's a running container. And then there are 3 different commands that we can send to a running Docker container. And what it does, so Docker pause, Docker stop, and Docker kill. And what it does is it's sending a signal to the main process of the container. So signals in Linux are a way of sending an event, a certain event which is defined what should happen to a process and letting it know that a certain reaction is required. So I made a list of those which are important in this case. You have probably called the kill command on your command line to kill a process, and the -9 meant that the process that you are sending the signal to should be terminated immediately. So it's just gone. And as I said, Docker pause, Docker stop, and Docker kill will also send the signal to the main process of the container. So zig stop just stops the container, and zig term is meant that that the main process of the container should send the zig term signal to all the child processes that it had started. And if it did not end all the processes, like after a grace period, which can be configured in Docker, if you don't configure it yourself, it's 10 seconds. So when you run Docker stop, and the container is not being stopped after 10 seconds, then it's sending the zig kill signal, which just forcefully terminates your container. And the zig term signal also means that you can, if your main process gets the zig term signal, then you can decide which other tasks you want to do in order to gracefully shut down all your services. So those are partly the responsibilities of the main process, which in a Linux system has the process ID1. So stopping child processes is, so when a container starts child processes and something happens, then the main process also always needs to clean up all the resources of its children and stop the child processes as well. It's called reaping. So when the main process is not well designed, then it might happen that some zombie processes are hanging around, and that's a bad thing, because a Linux system can only have a certain number of processes running, and if there are too many, then just the system will stop working right. So now I come to the actual challenge. And so before we had just this Dockerized dev set up, and now we were supposed to do a cloud migration. And we had so the setup did not work with the platform that we were supposed to migrate to. So there are some platforms. So ours was Azure App Service, and there are some similar ones. They expect you that you just deploy your one container, because like other languages do have a built-in web server, so they don't have a problem. But like it gets weird with PHP now, because we cannot simply like just deploy our one container. We are missing either the web server or the PHP, so that's not an option. And so we were looking into some options here. And Kubernetes was not one of the options we had, because we just wanted to deploy our simple, small, I say small, but like just a PHP application is like overkill with Kubernetes. So the team would have also be required to learn all Kubernetes things, and just for deploying a simple PHP application, that was too much. So Docker Compose would have been an option, but it was on Azure, still an experimental feature, and we were only allowed production-grade software, so experimental features were out of the way. No Docker Compose in production. And so one other option was Apache with modPHP. And I'm putting this on the list, but it was not the first choice. So I was not really researching it. It's just on the list, but like, so you know, like we were looking into it. But maybe if no other option comes up, then we look into Apache with modPHP again. 2 years ago, at the SymphonyCon in Paris, FrankenPHP came up, and I was very, very happy to hear of it. So because you can put your PHP process together with Caddy in one container. And yes, exactly the solution we were always looking for, just a simple container. And there were some things when I was looking deeper into it. So one of them was there was only one developer behind it, and the software is written in Go. So whenever an error was coming up, we were required to learn how Go errors are interpreted, and that was all not something we wanted to put on our PHP developers. So, and also FrankenPHP at the time was still in 1.0.0 beta, so also not production ready. That's why I was kind of like, okay, do I really need to look into Apache now? And then one of my colleagues said, hey, maybe you want to look into putting it all in one container anyway. And sorry for the image. Hey, maybe we can do it anyway. Like, we heard of it, like, why you shouldn't put multiple processes in one container. But there's a documentation page on Docker docs, which gives you a few options what you could do. So you could use a bash script, or you can use you can use supervisord. That's the other option that they mentioned. And when I started to look into supervisord, there was the first thing on the main documentation page. It says that that it should not be run as a substitute for an init system because it doesn't have a proper process ID1 functionality. So if you would ever be interested in what an init system is, an init system does a lot of things. And I'm not going into this right now because it's out of scope, but it's very, very interesting. And there are many init systems out there, and they are different and do things differently. And on one of those pages where I was looking into why and how you should use supervisord, someone mentioned they have now solved the problem with Essex overlay. And I was like, I've never heard of Essex overlay. What is it? So he's very satisfied with it, and they're running it. And so I started looking into it. And this is the first thing I discovered on the documentation page. I read it. So it's a container-focused process manager that offers end-to-end management of the container's lifecycle from initialization to graceful shutdown. And that's exactly what I was looking for, right? So what it does, it's changing the mantra from doing one process per container to doing one thing in a container. So this thing might be a chat service, or you run GitLab just in one container, or your Symfony application. It can have multiple processes, and it's totally fine. Because the container should now do one thing, and if it cannot do this one thing anymore, then the container should stop, because it's not healthy anymore. So I want to show you some key features of Essex overlay. The first thing is that it's very easy to integrate. I will show it in a few seconds. Then it has proper process ID1 functionality, so it will always clean up all its children. There will be no zombie processes hanging around. It's taking care of that. Then you get versatile process management, which means you can have single one-time scripts being executed in your initialization of the container, or you can have long-running daemons. And Essex overlay will run all of those. I'll get into that in a few seconds. And you can define the dependencies between the scripts or services and how they are depending on each other. And with that as well, like it's starting all the processes in the same order that you said that they are depending on each other. And you can use environment variables in the service scripts. You can have the handle for the std out and stdr. You will get passed that into your services with all scripts. So in Docker, whenever you want to start a service, then you need to define like where all the log information will go to. And when you start processes differently than with this init system, then you will not get the handle for you will not get the file handle for the stdr and stdout. And that's a problem, because then you cannot write to the same output. But with SX overlay, it just hands you the pipe to the stdr and stdout, and you can use all the outputs for Docker logs. Then you can add custom scripts where you can execute that are executed when the container is being shut down, so you can clean up all the things that you need to do. And which I think is one of the best features, it has a multi-architecture support. So if you start with Alpine and you realize that you need more of the system below, then you could just switch to Ubuntu with the same setup. So you're not bound to any architecture, because I mean, Alpine is using Musl and Ubuntu is doing glibc. It's a very different architecture, but you can still use the same configuration setup to initialize all your scripts and services. I want to show you now how it's implemented, or how you use it. So not the real implementation, but so this is how you install it. It's just one tar file for where all the base files are in, and then one tar file for your architecture. And there are for every architecture there will be a different tar file. This is how it supports the many architectures. And then one of the important things is here that the the entry point script must be /init. And this is where the supervisor will start. And there are two ways how you can use this image that I just showed you. So one is as it is. So you have some configuration and you start the /init script, and then it's supervising all the services. But you can use the same container and say you have a command, the cmd, and run a different script at initialization. And what happens here is you can use the same container, but use it differently. So if you run cmd, then the container will stop after this command is done with execution. And the other one with entry point /init would be that it's just running this server script as a long-running process. And for the configuration in SX overlay, the service configuration will be done in files and directories. So it's super simple. And I'll show you the 3 types of services that you can define. The first one are the one-shots, that are the scripts that run once and exit. Then the long runs, which will be supervised by S6. And the last one is the service type bundle, which will then help you to group related services. So, the one-shots. You will have this structure here, where you have a base, a root directory, where S6 expects everything to be configured in. So that's the root directory of all our service configuration. Then we create a directory for our service. And in there, we have 2 files. The first one is called type, and it has the word one-shot in it. And the second one is a file called up, and it contains a path where our script is actually living. So this one. Right, and we have a dependencies D directory where we will put in files with the names of the services that we are depending on. So those will be executed before our one-shot. And then we have the long-run type, which lives in the same directory, of course, but we create a directory for it again. We have a type file again, and the content is long-run. And we have an executable file where we actually start the daemon. I will show you the content in a few seconds. And then the last one and will be the bundle, which, as I said, you can group here related services. You have a contents D directory, that's the important thing, where you can add you put files in it with the names of the services that you defined before. So now I want to show you how fast you are with creating your first running container with PHP-FPM and NGINX, because that's what I'm here to show you, how simple it is. So we create a root directory, we create the initial structure, then we add our PHP-FPM service and an NGINX service, and then we just run it. So the root directory, I told you before, it's an S6 overlay, S6 RCD directory. That's what we create. And then inside there, we need to add the user bundle. That's the starting point for S6 overlay. So S6 overlay will look into this contents D directory and see which service you have put in there, and then compiles the dependency tree. And if it's done that and everything has compiled successfully, then it's starting to run the initialization and starts all the services in that sequence. So we create now the PHP-FPM service by adding a directory and adding the PHP-FPM service to the user bundle. Then we create the NGINX service the same way, except we have a dependency on PHP-FPM, because that needs to run before we run NGINX. Right, so there you have it. That's it. Then we run it. So let's see. We have the S6 service scan. That's our, you see here, that's the process ID 1. That's our main long-running process now that starts in the container. And it will supervise processes that will supervise the PHP-FPM and the NGINX service. And then here we see just the normal processes that we would always see in our NGINX or PHP-FPM containers. That's it. You don't need to do more. It's running. So the next step, you want to stop it. So you can do important things here. You can add a finished script. It needs to be executable. And you can do your important thing. And then also you can let the container know what you think the exit code should be. You have the option. You can do that. Then there are some things that help you to have an even more secure container setup by giving you the option to drop privileges, because some processes don't need to have the ability to do root things. So you don't need to run your services as root. You should not do that, right? So you can, so S6 has us covered here. You can just say S6 set UID GID and the user ID or the name of the user, and then run your service. And you can access the environment variables by putting with contenv, which means like the container environment. You put that inside your script, and then you can access all the environment variables. Or you don't put that into your script, and then the service that you start or the script that you run doesn't know anything about all the passwords that you set as environment variables in your container. There is a ton of environment variables that S6 will give you in order to customize the behavior of S6 overlay. And I'm not going into that now. I leave that to you if you are interested. And I think the documentation is good to describe you like how everything works together with those environment variables. One point I want to stress a bit again is the difference between what supervisord does and S6 overlay. So say you have a malfunctioning process, or just your PHP process doesn't come up right. Then with supervisord, the problem is the supervisor is running as a main process, and yes, the process is very healthy, because what it does, it's just restarting the PHP-FPM process, and it's doing that very healthy. But at the same time, no, our container does not work right, so our application will not be served. And we don't know about this because our main process says it's very healthy. S6 overlay is not doing the same thing. It knows that one of the processes that it supervises is not healthy, and it's saying, oh, this container is not healthy. And then we can do things about it. So we can fix problems, which the supervisord option is not really helping us with. So I come a bit to the end. Yeah, so I showed you why you should use an init system for containers with multiple processes. And I showed you why S6 overlay is exactly the kind of software, which I think, that was the missing piece between PHP-FPM and Docker. And I showed you a complete example of how you can simply set up your PHP-FPM and NGINX services so you can run your PHP application and simply deploy it in one container. And S6 overlay is here for 10 years now, over 10 years now, so it's well-hung software. You can not only use it in your container, you can use, so S6 overlay is a wrapper for running S6, the init system, in a containerized environment. But you can use S6 on your machine as well to just supervise processes. And it's built to be super, super stable. So that means it does not do any memory allocation or including any mailer daemons or anything else that it doesn't need to do in order to just start your system. So we are running S6 overlay containers now in our production environment, and we are very, very happy, and we did that now with all our applications, and it's really nice. It worked out totally fine, and I'm very, very happy. And yes, all the other solutions I did not need. And yes, I brought you some more recipes because we are running it now. And so out of that, we developed some solutions, which I want to show you now. So one is a one-shot that is doing migrations with every container deploy. So you deploy your container, and during initialization, it just runs migrations. And the other thing is I just recently needed to remove all the, I needed to move all the cron jobs that were running in the on-prem system, and I moved them to the Symfony scheduler. And then I needed to run the scheduler so as a long-running daemon. And so this is how it's running now. And it's a long run, and it's stopping after processing 10 messages, and it's or after 5 minutes. And then SX overlay is just restarting the worker again. So it's very nice. Nothing else needs to be done here. Or you can just check requirements in the development environment. So I ask here if Composer is installed, which is usually in the development container. And it can just check platform requirements. So there's a ton of options here what we can have as recipes in order to do all kinds of things that we want to have in our initialization process in our containerized environments. So, do I have still time? Still time? All right. So, I have simplified one thing even more. So what I did here is I put all the assets that you first saw in the on the first slide of how you install it. I put all that in a base image and pushed it, and I wrote some scripts that is always looking if there's a new version of SX overlay, and if it is, then it's building a new base image. And I can now just copy the assets from SX overlay from the SX root directory to my root directory, and I'm done. And the other one is, because I was interested in Go also, and this came up, so I built a small CLI for SX. And what you can do here is, if you run it, you can do different things. You can create a service or remove it. You can lint it, and you can run some documentation on it. I'll show you. So if you run create init dependencies, it will just create the structure for you, because sometimes there are some additional line breaks required, or some files need to be in the right place in order for it to initialize right. And I had the problem of like some cryptic messages, and I fixed it, and then I wrote this service where you can, or this CLI, so you can like have it simplified for creating services. And the same thing, like we included it now in our CI runs, so we can lint our services and how they are set up. And we can add this, if you say CLI mermaid, then what it does, it's outputting the markup for, or the markdown syntax for which will create this diagram. And this is what you can also include in your documentation if you want to like be a graphic person and want to a visual person, and you want to know and see how your services are all depending on each other and how everything is connected. This is the end. Thank you. It's good.
So thank you for your talk, and I look into the room for questions. Oh, I see one over there, in the fourth row, I guess. Fifth.
Hi. Can you explain, so I know S6 for quite a while, but I never had a use case for it personally. So can you reiterate on the use case again? Because from my point of view, writing a simple Helm chart or even vanilla Kubernetes or doing some abstraction is easier or the same complexity as you showed. So is the use case letting developers doing DevOps who don't know about DevOps, or did I get this right? Or
So we did not have the option for Kubernetes. We were required to deploy and migrate the application to Azure App Service. And this allows only for deploying one container. And we completely decided against Kubernetes because then the team would have been required to learn everything about Kubernetes and running services in Kubernetes.
I wouldn't say so that you have to learn everything. You just have to learn about services and little things. But okay, so in this you are bound to using certain technology, so you had to come up with a way to actually make it use with a different service. Okay, I got it. Thank you.
And also, it solves one more problem. If you need to build assets in your PHP image, and you need to share it with the NGINX image, like in the setup that we had before, and deploying with containers with two images behind it, then they need to share the same assets. And then you need to, I don't know, how, like I built the first service and then I copy the assets from one image to another image, and it was very complicated. And so because like you want to have the NGINX service serve your static files.
Yeah, but you can just use volumes which point at the same directory and share. This is how it
Okay, I would totally be against using volumes in production, because like if that would lead to, like, I don't know, things that I don't want to maintain.
Okay, that's a different point. But
Totally.
So I think Sebastian, one of the Sebastian, has a question.
Thank you so much. Actually, we also run it this way, like put everything for one application to one container, because it just helps. So actually we use Kubernetes often as well, but still we package everything together. But we were missing such an init system, so that fits us really well. I have a question, if it's possible, like if one of the, can you actually stop a service inside a running container? Because we sometimes have the use case, for instance, that for debugging or, you know, I want to prevent the system to send out 10,000 emails. I need to stop this one service inside this container now. Is such thing also possible? Or is it just like, if I stop this thing, then it just removes everything?
All right. So the question would be, do you need to stop while the container is already running? Or can you stop it not started?
Both would be probably an option.
All right, so that's exactly the question I had. I have asked the developer, because what I did is I put a sleep in it and exit 0, so it would just restart. And I had an environment variable in it, and it said, like, should I run or not? And if not, then just sleep and exit 0. But that's not the solution that the developer has in mind, because he says, what the services that you define are the services that should run. So everything that is in the contents D directory of the user bundle should always be the services that are started. But what you have is this S6 stage 2 hook. And you can add a pass to a script. And in that script, you can read in the environment variables and then define which services you want to remove from the contents D directory. I have a report online, and you can look it up. I wrote it already, so.
Thank you.
Thanks. So other questions in the room? I see no one else. So I guess we can check if any cake is left. Or if you've already eaten a lot. So thank you again for being here. And
Thank you.
it was and I think we will continue in 20 minutes time.